So last time we saw exception handling in Java. Now what exception handling does, as you know, it will always go for normal program termination. Now why I am typing this is because though you may have written a proper program, there is always a chance that your program gets terminated abnormally. Now this abnormal program termination may not be because of you. It may not be your mistake. But still, because of some external factors, the execution of the program may stop. To eliminate this possibility of abnormal program termination, as I told you earlier, we should be learning the concept of exception handling. Now I have discussed this earlier that exception handling consists of three things: the try block, the throw statement, and the catch block. Whatever part of program you wish to monitor for errors, whatever part of the program you think may lead to an error must be defined within the try block. You should not try to write down everything in try. What most of the people do is they put everything in the try block. That should not be done. The things to be monitored, the error that you may face, that things must be defined inside try. Now when you write a few statements in try, Java itself tries to monitor for errors. Now two possibilities may take place. The error may occur, the error may not occur. If the error doesn't occur, if the program works fine, then the normal execution of try block takes place. Neither throw nor catch comes into picture. Second possibility, if try block leads to an error, if try block captures an error, what Java does is, it analyzes the error and depending upon the error, it throws an object of the class which corresponds to that error. This object is then handled by the catch block. So basically throw will transfer the control from try to catch, ignoring the remaining statements of the try block. Now what catch has to do is, it has to react to the error that has occurred, either to rectify the error or if not possible, then always go for normal program termination. In earlier classes I have shown you people arithmetic exception, I have shown you number format exception, input mismatch exception, I have shown you array index of a bounds exception. There are few more exceptions. Today I will show you one program which is the best program to understand exception handling. I will show you two versions of the program. One where I write down the program without exception handling. Second, I write down the same program using exception handling. So, I will write down a very simplest of program. This is without exception handling. Now what I am doing here is defining a logic which may lead to an error, but when the error occurs, that is not known to us. See what I am doing. I define simple variables for you people. I will define a simplest of loop. So here I write down this loop. A very normal loop which will be executed 10 times. Now inside this loop, I generate the values of A and B using this, math.random. Basically math stands for the name of the class and random is a memory function of that class. But it returns a random number in the range of 0 to 1. So what I need to do is I need to multiply it with some value so that the random number is in the range of 0 to 100. We will typecast that value as integer. The same thing I do for B also. Math.random, again sum. Now the trick here is, I'll write down an expression. You need to focus on that expression, which will be something like this. The idea is that this expression will lead to an error at some point of time. Because what I have done is, the number 12,345 I have divided with A upon B. A and B both are generated randomly, and hence if A is greater than B, I don't know what the value of A will be or what the value of B will be, but if A is greater than B, then this A divided by B will be calculated. That will act as the denominator for this number 1, 2, 3, 4, 5. A normal calculation will take place, and that calculated value obviously will print on the user screen. This logic I have defined inside a loop which is executed 10 times. Now, when this is going to get executed, I don't know what the possible values of A and B would be. If A is greater, no issue. The calculation will take place, the value will be printed. But in some execution, if at all the value of B is greater than A, this will lead to 0. And if it leads to 0, as we have performed integer division, anything divided by 0, as you know, leads to an arithmetic exception, and that arithmetic exception will abnormally terminate this program and you will be thrown out of the program. But when exactly it will take place, in the first execution, second execution, or 10th execution, or it may not take place, I am not sure about it. So what I will do right now is I will just execute this program for you. See, the loop was supposed to be executed 10 times, and in the first execution itself, I got the arithmetic exception slashed by 0. Let me show you this execution for the second time. Now, this is to be understood. The program got executed properly for 3 executions, and in the 4th execution, I got the error. Again, let me show you the same working again. Twice it got executed properly, 3rd time it led to an error. So, looking at this program, I can say whether 10 repetitions will take place or not, I don't know. I'm not sure about it. But this is not the correct way of programming. We should program in such a way that whether logic that you have written has to be executed in all circumstances. What happened right now is the program was terminated in the first execution itself. The program got terminated after 3 executions. But 10 repetitions are not promised over here. So the same program I'll write down for you again. And let me put try and catch block in this. Let me put try and catch block over here. This much part. Because this is where division is taking place. So the division part I'll put over here. Catch, again, arithmetic exception. And let me write down the system.out.println wrong division. I'll simply print a message for you. So the only change that I have made in this program is I have put a try and catch block in this program. Let me re-execute this. See. Can you see what happened? Twice in the repetition of the loop, an error occurred. But see the beauty of exception handling. It did not terminate the program abnormally. 10 repetitions are promised in this execution. Let me show you the second execution. As you can see, 5 times the error occurred. Still, exception handling did not let the program to get terminated. And that's why we implement the concept of exception handling. So I have got 2 programs with me. One is without exception handling, one is with exception handling. This loop, I cannot guarantee how many times it will get executed. Here, I can confidently say that this loop will be executed 10 times, irrespective of whether an error occurred or not. Next, I'll take you to a new concept about exception handling. See, In the earlier class, I showed you this one simplest thing. I'll again write down the same thing. Int of C equals to say 100 divided by 0, and I try to print the value over here. System.out.println, and I'll print the value of C. This is bound to get you an error. Let me execute this for you. It's bound to get you an error. And it shows that the error occurred in the main program, on the 6th line of the main program. I'll do one thing, I'll just copy down this into a member function, into another method. Let me call that method as fn, and I'll write down the logic over here. And in the main program, I'll simply call the function. Earlier the error part was defined in the main program. Now the error part has been defined in the function. Let's see what happens in the execution. I got the same error, but now it tells me that the error occurred in fn on the 6th line, and fn was called from the main program. I'll take you one step further. I'll define one more function over here. I just wish to tell you how the processing is taking place. See, main calls fnn, fnn calls fn, and the error occurs in the function called as fn. Again, let me show you how execution takes place, how processing takes place. Error is the same, arithmetic exception where the division took place by 0, but the error occurred in fn, which was called from fnn, which was again called from main. So it's basically telling us that error has occurred in fn. fn was called by fnn, which is the parent part. fnn was again called by main. So main is the grandparent, fnn is the parent, and fn is the child program. Now, new thing for you people. The error occurred in this function. As you can see, there is no try and catch block. Now, the best possible scenario would be fn should have its own try and catch. The child function fn should have its own try and catch. But unfortunately, as you can see, it doesn't have its own try and catch. So we should try to put try and catch in fn itself. But if it doesn't have, then there is one trick. The function which calls it, remember fn is being called from fnn. fnn can rectify that error. fnn can catch that error. For that, the calling of fn can be put inside try. Something like this. See what I have done. The error is in fn, handling has been carried out in fnn. But for that, fn has to be called from fnn. Secondly, fn has to be called from inside the try block. So now, if I try compiling this, if I try executing this, you can see the error has been eliminated. But the thing to be understood is, error happened in fn. It is not handled in fn, but it has been handled by its parent function, which was responsible for its calling. And hence, you can see wrong division has been caught in fnn. See it again. Error happened here. There was no try catch, but the function which called the function fn, it has handled the error over here. So if child commits some mistake, it can be handled by the parent function. But I will show you one thing. Let me do this. Can you note the difference? That try catch is not calling the function fn. The function fn, though being called from fnn, is called normally without try catch. Please note this, what happens. When I execute the program, the error still remains because it did not find a try and catch. So you need to understand that this calling of fn has to be done inside the try catch block only. One more thing. This function led to an error. If it had its own try catch, the problem would have been rectified there itself. It won't have come to fnn to rectify. But because it does not have its own error handling mechanism of try and catch, it has been caught by the parent function called as fnn. Now see, there may be a situation where fnn has already caught the error of fn, things have been sorted out. But still, fnn thinks that the error has not been solved properly. It wants the error to be rectified by the boss, by its parent, by the grandparent of fn. This fnn needs main to go through the error process again. I'll do one new thing for you people. First time in exception handling, I'll write down throw. As discussed earlier, throw is done internally. Throw has to be performed. Throw is done internally by Java. It does not involve me. I don't have to use the throw statement in Java, but here I am using throw. This is called as manual throwing of an exception. What I'll do is, I'll throw an object of the class arithmetic exception. I'll write down some message over here. Something like this. I'm manually throwing, so it has to be caught somewhere. I'm doing the manual throw over here. One thing I'll do in the main program is this. Catch. Again, arithmetic exception. System.out.println. Wrong division. 14. See the magic happening over here. I'll just tell you the program from start. Execution, as you know, will start from main. Main makes a call to a function called as fnn. Fnn gets called. It doesn't do much. What it does is, it simply makes a call to another function called as fn. So the transfer is now taking place into fn. Here division took place and somehow an error happened. That error is called as arithmetic exception. I again say, fn should have its own try and catch, but as it doesn't have it, the execution got transferred to the parent function and it successfully caught the arithmetic exception error. Rectification took place. But it was not confident of the solving technique or the rectification logic. It wanted the error to be handled by its parent. So manual throw took place, and what I did is I threw an object of the class arithmetic exception that was caught in the main program, and you can see the execution now. Error took place in fn. It was first caught in fnn, and then the error was referred to main, and the error is again caught in the main program. So not necessarily always the error will take place over here, and it will also have try and catch. The try and catch can be placed in the calling function. Here I could have done one thing, new word for you people. I could have written this in the signature. Kindly note, it's not throw, it's throws. Here I wrote throw. Here I am writing throws. What throw does is, when an error occurs, it transfers the control to the calling function or to an appropriate catch block. Throws is something different. In the signature of Fn, I have used the word throws. It tells a programmer, when a function definition contains the word throws, it tells the programmer that this function may lead to such type of an error, and it is clearly accepting that it does not have its own try and catch. So what does the programmer need to do? Whenever a programmer calls such a function, it has to define a catch block which handles the arithmetic exception. So it becomes the moral duty of the function to define a catch block which should handle this particular error. I could have written something like this also, see, runtime exception. I could have written a list over here. Illegal access exception. So what the function is basically telling is, it may have these three possible conditions of error. It is clearly admitting it has not handled the error. So whichever logic calls this function, it is bound to call it using try and catch. So it's indicating that I have not handled such an error in the function. So I have the fourth part in front of you about exception handling mechanism, and that is the throws. This is different. This was throw. It transfers you to an appropriate catch. This does not do anything, but it tells a programmer that this function leads to an error, and this error has not been handled locally. So whichever function, whichever logic will call this, it has to be ready with a try catch block handling this particular error. Now after this, there is only one thing left in exception handling, and that is the keyword finally. I have discussed it earlier. There are two words in Java which are a bit confusing. One is final and another one is finally. Final is different. That was used to define constants, that was used to stop overriding, that was used to stop inheritance of classes. This finally in exception handling is going to be a bit different. That I will be handling in another class. What you need to do is, whatever programs I have given over here, you need to execute these programs. You need to try executing this on your own. Try different variations while you are executing the program. The more you play with the functions, the more you play with the logic, you will try to understand what exception handling actually means. Secondly, this concept of exception handling will be now used regularly in all your further Java topics. Everywhere I'll have to write down a try and a catch and everything. For that, you need to understand this properly. Okay? So what I am expecting now from you people is to execute these programs, to write down your programs, to try variations in the execution, and try to get a feel of what actual exception handling mechanism means. Okay? So next video will involve the finally block, and I'll start with the new